Web pages include hyperlinks, which are pointer to other web pages. A hyperlink contains the URL of the web page to find when the user clicks the hyperlink. The URL can reference a page on the server that generated the page containing the hyperlink, or it can reference a page on another server. Until 2010 or so, organizations constructed and maintained their own computing infrastructure. Organizations purchase or lease hardware, install it in their premises, and use it to support organizational email, website, e-commerce site, and in-house applications such as accounting and operating system. After 2010, organizations began to move their computing infrastructure to the cloud, and it is likely is the future for all, or nearly all, computing infrastructure will be leased from the cloud. We define cloud as the elastic leasing or pool computer resources over the internet. The term cloud is used because most early diagrams of three-tier and other internet-based systems use a cloud symbol to represent the internet, and organizations came to view their infrastructure as being somewhere in the cloud. The term elastic, which was used this way by Amazon.com, means that the amount of resources leased can be increased and decreased dynamically and programmatically, and in a short span of time, and that organization pay just for the resources that they use. The resources are pooled because many different organizations use the same physical hardware. They share the hardware through virtualization. Cloud vendors dynamically allocate virtual machines to physical hardware as customer needs increase or decrease. The resources are accessed via Internet Protocol and standard, which are addition to TCP/IP that enable cloud hosting vendors to provide processing capabilities in flexible yet standardized way. Figure 6.15 compare and contrast cloud-based in-house hosting. Positive. Once you lease a cloud, you may obtain and access the server today, actually within a few minutes. Tomorrow, if you need thousands of servers, you can readily scale up to obtain them. Furthermore, the user knows the cost structure. Another positive is that as long as you are dealing with large, reputable organizations, you will be receiving best of breed security and disaster recovery. In addition, you need not to worry that you are investing in technology that will soon be obsolete. The cloud vendor is taking that risk. All of this is possible because the cloud vendor is gaining economies of scale by selling to an entire industry, not just you. The negative of cloud computing involves loss of control. You are dependent on a vendor. Changes in the vendor management, policy, and prices are beyond your control. Further, you do not know where your data is located, nor you do not know how many copies of your data are there. Finally, you have no visibility in the security and disaster preparedness that is actually in place. In fact, cloud-based hosting has been around since 1960s, long before the creation of PC and network. Time-sharing vendor provide slice of computer time on a use fee basis. However, the technology of that time up until first decade of this century did not factor the construction and use of enormous data center. Three factors have made cloud-based hosting advantageous today. First, processor, data communication, and data storage are so cheap us to be nearly free. At the scale of a web farms, of hundreds of thousands of processors, providing a virtual machine for an hour is essentially nothing, as the 1.5 cent of a dollar price per hour indicates. Second, virtualization technology enables the near instantaneous creation of a new virtual machine. Third, new internet-based protocols and standards have enabled cloud hosting vendors to provide processing capabilities in flexible yet standardized way. The bottom line, web service standards provide a vocabulary and grammar for programs on different computers to communicate. Cloud-based hosting makes sense for most organizations. The only organization for which it may not make sense are those that are required by law or industry standard practice to have physical control over their data. A financial institution, for example, might be required to maintain physical control over its data. Even when physical control is required, it is possible for organizations to obtain some of the benefit of cloud computing in what is termed the private cloud, which is in-house hosting delivered via web service standard that can be configured dynamically. Some say that there is no such thing as private cloud because the infrastructure is owned by the using organization and the economies of scale cannot be shared with others. Figure 6.16 illustrates the cloud-based service can be organized into three categories: software as a service, or SaaS, and PaaS, platform as a service, and IaaS, infrastructure as a service. Organizations that provide software as a service provide not only hardware infrastructure, but also operating system and application program on top of that hardware. For example, Salesforce.com provides program for customers and sales tracking as service. Microsoft provides Office 365 as a service. Exchange, links, and SharePoint application are provided as a service in the cloud. On platform as a service, vendor provide hosted computer and operating system and possibly a DBMS. Microsoft Windows Azure, for example, provides server installed with Windows Server. Customer of Windows Azure then add their own application on top of the hosted platform. For example, Microsoft SQL Azure provides a host with Windows Server and SQL Server. Oracle On Demand provides a hosted service with Oracle database. For PaaS, organizations add their own application to the host. PaaS is feasible because the widespread acceptance of critical web standard protocol for inter-program communication and data sharing. This standard, known as Web Service Standard, specify how web browser and other program can determine the service offered by a PaaS program, how to send and receive data to such program, how to query and process PaaS databases, and so forth. The most basic cloud offering is Infrastructure as a Service, or IaaS, which is the cloud hosting of bare server computer or disk drive. Amazon EC2 provides bare server, and its simple storage server provides, in a sense, unlimited, reliable disk drive in the cloud. MIS in 2014. The cloud brings the good and bad news. The good news: organizations can obtain elastic resources at very low cost. The bad news: perhaps cloud will reduce job, almost all server-related job. Maybe only a small fraction of the worker will work as operation staff in the cloud center or location. Perhaps cloud will foster new categories of work. By 2024, everything will be connected to everything else. With most data stored in the cloud, new categories of product and services will emerge that should create jobs. Remote access system will provide computer-based activity action at a distance. For example, telediagnosis, which healthcare professionals can use to provide expertise in rural or remote area. Telesurgery uses telecommunication to link surgeon to robotic equipment at distant location. Tele-law enforcement, such as uses cameras and motion sensing equipment to issue tickets for red light and speeding violation. By 2024, with everything hosted and everything connected, tele-action can afford to move beyond high-value industry to lower-value service. For example, the world-best figure skating coach provide high-value instruction to skier on any mountain all over the world. However, the need for local support staff increase with tele-action. The remote hospital may not need its own mediocre heart surgeon, but it will need staff who can prepare the patient and local equipment for the remote surgeon. It will need a local anesthesiologist, local nurse. This is also true for remote figure skating coach. Someone needs to be on scene. Tele-action also increase the value of robotic. Someone needs to design, build, market, sell, and support the machine that are on the other end of the expert action. If the value of the expert increase, so does the value of the robot. This is the end of chapter 6. Thank you.